There we go. 7.3 part 2. All right. Last week when we did growth and decay. No, this was way before. No, we did do this 2 days ago. We did inverses, right? 2 days ago was that Monday? See, really, you're an excellent student. You're on top of things. We did the inverses where I had y equals the log base b of x. Its inverse was what? See, and you blame me for not remembering 2 days ago. What's the exponential form, right? B to the x. Yeah. And it goes back and forth. You can go either way, right? So if you look at the first problem we have here, let's take a gander at 10 to the x and take a gander at y equals log. By the way, that's common log, so what's my base? 10. What can we say about these two? Well, they're not the same, but they are inverses of each other. Very good. I knew there was a reason why I had to record this class. So they're inverses. Huh? Huh? What? I don't know. What's going on? I don't know what's going on. All right, so we all know what this graph is because last week we did growth and decay, right? Oh my goodness. Where we had b to the x, and this is my b is greater than 1, so I know that this is growth. If it was a fraction between 0 and 1, it was decay. You know what I wish I really had? No, but that's a great idea. I thought of see now I'm getting off topic and I'm gonna have to pause.
Oh yeah, Nerf gun. That's better.
All right, so I'm gonna go ahead and graph this. This is obviously going to be growth exponential form, right? Um, be careful. We were using calculators in our stats class, and make sure all these plot things are off. If they're on, they're going to be darkened. See? Make sure they're off. Just hit the enter button. Turns them on and off. Okay? So I'm going to go ahead and put 10 to the x on there. I'm going to graph it. All right, and there's my graph. Looks like our growth graph, right? Going to get some points. So I'm going to go to my second graph. And let's see. I'm going to grab this point, negative 1.1. And the next one is 0, 1. Hey, what's special about that point? Y-intercept. Wow, that was quick. You may have been the quickest one today. Keith was pretty quick too, though.
Oh, Keith,
Of course it was.
Hey, Keith is a smart boy. He is. Though. He's smart. He really is. He may never stop talking, but he's smart for never stop talking.
Especially in U.S. history, he's in the last hour. He knows everything.
He's a god at everything in general.
Really? He doesn't. He talks, but he doesn't seem. Maybe you sure it's the right Keith?
Yeah, that's
What Keith are you talking about?
He's tall.
Brains, yeah.
They say he's tall. He always has his foot up on a chair.
He actually is does work in here, huh? Must be me.
Maybe he just doesn't matter. Maybe he just likes math.
Maybe. Next one is 1, 10. And the other one is to 100. Hey, do you guys want to spend some time here and go out to 100? Sure, because I could do it. All right, so let's plot these points. Let's see, negative 1.101, 110, and 2 and 100. Here, let's start going. 11. Okay, and then we draw our graph, right? So it looks like it's hugging the x-axis here, but never touches or crosses it, right? And then it goes up here. Kind of like that, right? So if it never touches or crosses the x-axis, by the way, what's the equation for the x-axis? That's right, y equals 0. See how we got the y-intercept. Anyway, it's y equals 0 because 0 doesn't have a value. So it's acting as a. Remember when we did growth and decay? We had horizontal asymptotes, right? So there's my graph. Yeah, obviously, since they're inverses, we're going to have a vertical asymptote, right? So the intercept here, we talked about that, is now you could put the ordered pair, but I'd rather have you put what y equals, because that way we know it's a y-intercept very easily. Y equal 1, right? The asymptote we talked about is y equals 0. The domain, you guys remember the domains for growth and decay? Yeah, negative infinity. And then I know it doesn't look like it, but this does go out this way. The x values, right? Negative infinity, positive infinity. And the range. What's my smallest y value here? What is it? Careful. Y value. 0, right? It's trying. Look at this. It's trying to get to 0, right? But because it doesn't touch or cross that 0, we're going to use a parenthesis, right? Okay. Where does my y stop? Good. And these 4 boxes here, we want you to do double the work, so just fill them in, okay? No, I'm just kidding. It's kind of like a typo thing. Wow. Did I hear some nasty language on that? Okay, now we could do the exact same thing for the log function. But we could easily do this if we know our inverse properties, right? Anybody remember any of the inverse properties? 6.7? Anyone? Anyone? And Bueller? Bueller? How about this one? This one's a really cool one. My domain and range do what? Flip or switch, right? Okay, there's another really important one we can use. They reflect, don't they? Remember? They reflect about the. Oh, you guys are bad. They reflect about the y equals x line, right?
Oh, isn't that like that? Like
Diagonal thing. Yeah. So let's put that in there. Let's put our little diagonal line in there. All right.
So is it cost 0?
Uh-huh. That's my y equals x line. So to accurately graph this, this thing is just gonna flip over, right? But we can even get it more accurate. Our domain and range flip, right? So I'm just gonna flip my x and y's. So point 1, -1, 1, comma 0. By the way, what's this point? Yes, it is 1, 0. If this was the y-intercept, what do you think this is? Yeah, x-intercept, right? Okay, so I got 110 becomes 10, 1, and 2, 100 becomes 102. So we can go ahead and plot these points. Point 1, -1, 1, comma 0, 10, comma 1. Look at that. Doing it without a calculator. Look at that. Wow. Intercept, we already said now we have an x-intercept. So x is going to equal 1. Here we had a horizontal asymptote. So what do you think we have here? Vertical asymptote, which is going to be our y-axis. By the way, these are parent. This is parent function. Okay, so my asymptote is, in the equation for the y-axis, x equals 0, right? Again, we could sit here and try to, in our heads, figure out what's going on with the domain and range, or we could cheat. We already got it for the exponential. Just flip them, right? So my domain becomes my range, -infinity, +infinity. And my range becomes my domain, 0, -infinity. What else can we, what other patterns can we get here? Anybody see it? Our asymptote, now we're looking at just a log function, right? Our asymptote, x equals 0, starts our domain. Yep. Our our asymptote starts the domain, goes out to +infinity.
The other one, do they start in range?
And the range for logarithms functions, -infinity, +infinity. Okay, and that's just for the log. For the exponential form, the domain's always -infinity, +infinity. So either way, if you want to put it in the calculator, draw yourself a table, do all this stuff, and then come up with the intercept, asymptote, domain, and range, that's fine. I think it's just as easy just doing the transformations and doing it without a calculator. By the way, do you guys remember the transformations? I warned you at the beginning of the year that we're going to have transformations applied to all the new functions that we do. This, remember, this is my h inside the mathematical symbols. Outside the mathematical symbols, my k. and then I have an A here. That's kind of like the slope or the steepness of the graph. What does my H tell me? Left or right. And we go the opposite direction.
And the K tells you up or down what you follow sign.
Yes. Okay, and the K tells us up or down. Same as the sign, same direction as the sign. Okay, how about the A's? Anybody remember the A? It's going to tell us stretch and compress, right? For the log function, if my A is greater than 1, it's going to stretch it. If my A is between 0 and 1, or a fraction, right? Like 1/2, 3/4, but not an improper fraction like 5/3, because that would be greater than 1, right? It's going to compress. And then the other transformation we had was if A was negative, yeah, it flipped or reflected, right? That's going to be an issue with the log function, and I don't think we'll get into it. Okay. All right. So, you guys want to try this without a calculator? Like I said, I think just looking at it, I can tell where this graph is going to go. So we could try it that way. What's my transformations here? I have log of x plus 4. Good. Okay. What's my vertical? Does anybody know the vertical asymptote? Well, let's look at that. Okay. So the transformations. I know that this crosses my. This is the parent function here. I know it crosses my x-axis at 1 comma 0, right? So if I start at 1 comma 0 and move to the left 4, 1, 2, 3, 4. There it is. That's my turning point. That's that point where it starts shooting off, right? What's going to be my vertical asymptote here? Look at this. This is 1, right? 1 comma 0. My x is 1. Where does it try to go to? 0. So here my x is negative 3. Where's my vertical asymptote going to be? 4, negative 4, right? Okay. My vertical asymptote is going to be x equals negative 4. Because it's shifted to the left 4. And then this is going to go out to the right. That's kind of like my turning point. There's my graph. I know that the range for all my log functions is negative infinity, positive infinity. And I know that my domain is going to be my asymptote value, which is negative 4, right? Negative 4. And it's going to go out to infinity. So I think it's easier to do it without a calculator. By the way, did you notice something where my vertical asymptote is? Notice anything where that is?
I'll be sure.
Oh,
Did we just do that?
oh, my vertical asymptote is x equal h.
Since no one else is speaking, I'll speak.
There's vertical asymptote x equal h. Right? My h is -4 because that's supposed to be a minus sign in our. Yeah, if you look, the formula's back here. Right. Pretty cool, huh? Makes our job even easier. But like I said, you could always put it in your calculator, make a little table, and come up with all those things. But I think it's easier just to follow the properties. What's my transformation? By the way, the natural log is the same as regular common log, right? Right two. What's my vertical asymptote? X equals +2 because I already have a minus sign, right? What's my domain? My vertical asymptote value going to positive infinity. And what's always my range? Like I said, you guys can go ahead and use that calculator, but I'm not. Okay, I have a vertical asymptote at 2. There's my x equal 2 line. I know I'm going to shift to the right 2, so I start at that intercept 1 comma 0, right? 1 comma 0, I'm going to go to the right 2. That gives me that turning point. Oh, here's my graph. Like I said, you guys are more than happy to use your handy dandy calculators, but I think it's easier just to know your inverse properties or properties of the graph. Next one, what's my transformation?
Down 5.
Down 5. Okay. So here's my 1 comma 0. I'm going to go down 5. 1, 2, 3, 4, 5. So I know that's my turning point. It's going to start turning, go that way. What's my h for the vertical asymptote? 0, because I'm minusing 0 here, right? So x equal 0. It's my vertical asymptote, which also becomes my domain value out to infinity. And what's always my range? So let's see if we could sum this up. Transformations. My h is the horizontal shift, right? Horizontal shift. My k is vertical shift, right? Up or down. Vertical asymptote, x equal h. Domain, we use that x value for the start. It's always going to go to positive infinity. And then my range is always going to be look at that. There's something you should put on a note card for the quiz Friday. I might just put this little chart on there for you. Questions, comments, concerns?